Hereby, I open this academic ceremony in which Vageesh Saxena will defend the academic thesis connecting online criminal behavior with machine learning using authorship attribution to analyze and link potential online traffickers. Mr. Saxena, may I invite you to present a summary of your study and the conclusions of your thesis.
Thank you. Dear Pro-Rector, highly esteemed committee members, colleagues, friends, and family. In the next 15 minutes, I'll provide a brief summary of my PhD research. But before I do that, let me provide an important disclaimer. Some of the content in this presentation might come as disturbing to some individuals. With that in mind, let's start with the introduction. Cybercrime refers to crime committed online through the internet. An estimate suggests that a huge proportion of revenue from all crimes in 2023 came through cybercriminal activities, and this is only expected to skyrocket by 2028. Among many cybercriminal activities, we limit our focus to only developing a proof of concept to connecting online trafficking activities on darknet and escort market platforms. The goal of this research is not to identify these trafficking activities directly, but rather to connect them so law enforcement can make use of this connection as a starting point for their investigation. So what is darknet? Darknet sits at the deepest layer of the internet, facilitating illegal trades and activities through the advertisements on online markets. As it turns out, drugs dominate all darknet activities, and these operations have been only increasing over time. Similarly, human trafficking activities, especially sex trafficking activities, have also increased online, with majority of them happening on social media, classified web pages, and freestanding web pages. So what prevents law enforcement from shutting down these markets? Here is an example of how an advertisement on darknet market looks like. The first challenge is the anonymity provided by these platforms that prevents anyone from linking these advertisements directly to the criminals. These advertisements also contain huge amounts of deliberately injected noise to fail most automated systems. Not everything on these markets is illegal, so not all activities can be directly shut down. There's also a movement of criminal across these markets, preventing law enforcement from pinpointing them. And finally, thousands of new accounts show up every day, and law enforcement only have limited resources to tackle all of them. Here is an example of how an advertisement on online escort market looks like. And just like the darknet markets, these markets also suffer from many similar problems. Additionally, unlike darknet markets, these markets lack usernames that can otherwise lead to connection of advertisements, at least some of them. Finally, practitioners have established a list of human trafficking activities that can be understood through trafficking networks. These networks can only be established when connected together through online advertisements, and in the absence of user ID or any other private identifier, this becomes extremely challenging. Luckily, there has been a rise in AI application, which if applied responsibly can lead to a positive impact, especially in this context. Now, while during my PhD research, we made incremental steps, slowly moving from darknet to online escort markets, but given the similarity and challenges in these markets, this presentation would only cover the application of machine learning methods applied to online escort markets. That said, we believe that our developed methods can be applied to any online criminal market. So let's understand how can we apply these AI methods to connect potential trafficking activities on online escort platforms. In the field of forensic science, authorship analysis methods have long been there, and they have been used to verify individuals through their writing, painting, and speaking styles. Authorship attribution methods are simply the application of those forensic analysis methods applied through machine learning. These methods are divided into two tasks. The first one being the authorship identification task, which focus on determining whether a piece of text came from one of the several known authors. In the second task, we try to determine whether the two pieces of text came from the same author, regardless of their identity. Since we deal with online markets here, the author of these advertisements are called as vendors, and so we call these tasks as vendor verification and vendor identification task. And this goes without saying, but the same principles can also be applied to images and audios. Now that we know what authorship attribution methods are, let's understand why should we apply them to online escort markets. Previously, we saw that practitioners study the behavior of individuals or organizations in criminal networks to understand whether an escort market is a legit service or a potentially human trafficking activity. But in the absence of vendor names or private identifier, it becomes really difficult to connect these advertisements all together. Through authorship attribution methods, online advertisements can be connected together in a structured knowledge graph, which can help law enforcement study these behavioral indicators better. This brings us to our research questions. In the first question, we investigate whether writing styles, consisting the use of tone, spatial symbols, and grammar in the text advertisements can be used as a forensic signature to connect vendors online. In the second question, we explore whether photography styles, consisting different poses, lighting conditions, and backgrounds in the image advertisements can be used as a forensic signature to connect these vendors online. And in our third question, we explore if combining writing styles with photographic styles help us in better connection of these vendors. But before we do that, we need to create inputs and outputs for our machine learning algorithm. We collect our data from Backpage Escort Market, platform that operated between 2004 and 2018 in the United States, facilitating many sex trafficking operations. To create the input text sequence, we simply merge the title and the description of these advertisements. For input images, we simply take the images from the advertisements as it is. And since the user ID in these advertisements were missing, we instead extract the phone numbers from the text advertisements and merge them together to create vendor communities, which serves as proxy label for our vendor identities. In total, we collect our text data from 14 states and 41 cities of United States, but only 7 of those cities had text and images together. So for our analysis here, we are only going to consider the advertisements from those 7 cities. We distribute all the advertisements from these 7 cities into 4 geographical regions, namely South, Midwest, West, and Northeast. And so in our first experiment, we feed the text description and the title of the advertisement into our model, and we try to identify whether the model can predict which of the known vendor it came from. This model helps us to connect vendors that exist across multiple South region markets. As it turns out, the text-only model achieves an accuracy of about 78%. Similarly, in our second experiment, instead of feeding the text advertisement, we feed the images. Here, the model achieves an accuracy of about 77%. And finally, in our third experiment, we feed both the text and the images from the advertisements together. And in this case, the accuracy reaches about 98%. So clearly, the combination of photometric styles with writing styles is helping the model perform better identification tasks. But while this method works really well for the vendors known to the model, there exists a major limitation. This method fails to accommodate any new coming vendor outside the ones it knew during the training. So in a sense, this method works as a closed box. To make it accommodate or process advertisements from new emerging vendors, we take the trained model, which we had in our step earlier, and make it open to create what we call as embeddings. These embeddings are numerical representations of the input data that was fed to the model. The benefit of creating these numerical values or embeddings is now that they can be plotted on a high-dimensional representational space, which can be used to form cluster of these vendors together. So here, for example, the blue advertisement in a cluster of red advertisements suggests that the blue and the red vendors might be connected together and might be potential aliases of each other, because not only these vendors write similarly, but they also post similar pictures. Additionally, we also see a new cluster with purple vendors that was previously not known to us. This represents new upcoming vendors. When evaluated against each other, we see again that the model that takes both the writing and the photometric styles together outperforms the other two models. It is also very interesting to see that the extra boost in performance remain consistent, not only on the training dataset, so the dataset that was shown to the model during the training, but also on the unseen dataset the data sets that were never exposed to our model during the training time. And this shows some sign of generalization. As illustrated, while our authorship attribution methods work, their unregulated application can lead to ethical, legal, and social problems like privacy violation, decision-making biases, and potential misuse. So this brings us to our final research question. How can we establish an ethical framework that promotes responsible use of these authorship attribution methods? So grounded in existing AI literature, we created a framework of responsible guidelines that is built upon 4 pillars. These pillars are privacy and data protection, fairness and non-discrimination, transparency and explainability, and finally, positive societal impact. Furthermore, after studying the authorship attribution software development life cycle, we assign roles and responsibilities to the stakeholders involved within the planning, development, and deployment phases. This helps us establish accountability. In total, we established 31 guidelines as questionnaire and perform a case study to simulate how these guidelines can be potentially applied to real-world scenarios. In conclusion, we show that while text advertisements and image advertisements can be used to connect vendors online, the combination of them being used together leads to better identification process. In the absence of ground truth on online escort platforms, phone numbers can be extracted directly from these text advertisements, which can serve as proxy labels for the identification task. The same model can also be opened up to form clusters of vendors, highlighting potential aliases and emerging vendors. And finally, we show that through ethical principles of privacy, fairness, transparency, and positive societal impact, authorship attribution methods can be regulated to create more responsible and trustworthy applications. While it may seem like that our methods work, they are not without limitations. Just like any other machine learning methods, not only our methods are computationally expensive, but they also rely on high quality labels. Most of the data sets and the advertisements we experimented on, they predate 2018, and they are mostly in English. Also, they all came from the same platform. So there needs to be an investigation conducted to really validate the applicability of these methods in an environment where the advertisements belong to multiple languages, but also they came from multiple platforms. These methods are currently lacking the element of model explainability, which can really help to establish trust and reliability amongst law enforcement. There has been a rise in the LLM application, the field of large language models, and currently we do not know if these vendors are writing the advertisements themselves or if they're using large language models to write it for them. In the latter case, the element of stylometry becomes questionable. And finally, everyone would benefit if these models can learn from human in loop and vice versa. For our responsible guidelines, not all guidelines that we developed can fit every authorship attribution task, and so these trade-offs must be managed by the stakeholders involved in the application. Currently, these guidelines are only implemented for text-based authorship attribution scenarios, and so there needs to be an extension of these guidelines for image-based authorship attribution tasks. And finally, we need to really validate these guidelines in a real-world scenario, so there is a need of testing them. Through our research, we create many resources, including the papers we publish, the code we develop, which is available on GitHub, and the data sets that we publish on Dataverse. With that in mind, I would like to finally thank my supervisors, collaborators, and my team, and finally for all of you sitting here and for your attention. Thank you so much.
Thank you so much, Mr. Saxena. Thank you for the beautiful pictures. The opposition will be opened by Professor Nelen. Professor Nelen chaired the assessment committee and is a professor of criminology at our Faculty of Law. Professor Nelen, the floor is yours.
Thank you very much, Pro-Rector. Dear candidates, you've written a very interesting and fascinating PhD thesis, I must say, that addresses a very topical and relevant issue For me as a criminologist, I know, of course, there's a lot going on online markets. And when we talk about cybercrime and those kind of issues, it has, well, increased attention from our field of study. And your goal was to introduce a responsible authorship attribution approaches to support practitioners, both researchers and law enforcement, in analyzing, linking, and investigating cyber-enabled trafficking operations on online platforms, particularly the escort market. And I think you definitely succeeded in that endeavor, and I want to compliment you for that in the first place. Also, in relation to your writing style, which is accessible, reader-friendly, and I must say I learned a lot from this PhD about machine learning, about authorship attribution in general. Although I must admit, sometimes I got lost a little bit in the technicalities that are presented in various chapters. I thought, ooh, this is quite complicated, but I have a number of colleagues that can very well assess that. My overall impression is a very positive one, but of course there are always questions, and I want to raise one in particular because it's clear from the start that what you try to do and what you just explained to us is very relevant for law enforcement in terms of risk assessments and those kind of things. But I'm still a bit puzzled about the academic added value of your work. So I'm looking at, okay, what does it really add up to the academic literature? And you added parts of that in the version of your PhD at the end in chapter 8. But still, I want to invite you to elaborate a little bit more on especially this academic added value. Is that related to, well, theory, the development of theory? Is it related to the way we tend to look at risk assessment more in general? Is it related to methodology and from your point of view in terms of, because I get the impression that you emphasize the fact that the study contributes to new empirical strategies, so it very much seems to go in the direction of methodological development, which is, I would say, of course, very useful and very beneficial. But I'm still a bit puzzled. Also, maybe it's the added value lies in your analysis and your guidelines, your framework at the end of the study in chapter 7. So when you look at it, when you look back and you think about the academic contribution that you made, where does it actually, can you elaborate a little bit on that aspect, where the academic value of your work lies?
Highly esteemed opponent, thank you for all the compliments. As for the answer for your question, as per me, I would say the academic value lies in opening the authorship attribution task to simultaneously perform the identification and the verification process. So if you go back to the literature, either the focus has been either on the identification task or the verification tasks. And researchers, they establish their models by training on very specific goals. So either they want to create these verification tasks where they want to cluster all the advertisements from the vendor and then find similar writing styles and patterns, or they want to do this task of classification where they have a list of pre-known authors and they just want to pass a piece of an artifact and try to learn from the patterns from this artifact and attribute it to one of the authors. Now, the problem with both of the approaches is that for authorship identification task, which is the classification task, as I also explained it in my presentation, that while that works pretty well, it cannot accommodate any new coming vendor. And so especially in our context, these new coming vendors or advertisements, they just come on these markets every day, right? So this is a very key problem for us. And therefore, we need to make models so that not only they can be used on the known vendors, but also on the emerging vendors. In this research, we tried to open up the model that was fixated on learning from the closed set environment to an open set environment. So initially, we make our model learn these patterns and these writing and photometric patterns from the data that we provided, associated it with the known vendors. But then we also use the capability of our model to work in an open setting where it can actually identify potential aliases and also the new coming vendors. So according to me, that would be one of the primary contribution we made to the field of academia, that we created at least a methodology around how can these models be opened up to do both closed set and open set tasks. Secondly, we released 2 novel datasets through our research, namely ID Traffickers and Match. So earlier, for the authorship attribution task, none of the datasets were directly targeted towards escort markets. And we released these datasets in a very ethical manner by masking as much data as possible, which helps also to prevent the misuse from these models. Thirdly, we promote this idea of retrieval over one-on-one similarity comparison. So either you can achieve authorship verification task by some kind of metric learning method, which we also explore in our chapter 4. But we suggest that that would be very computationally expensive, and so we can use similarity search to perform retrieval directly over those cluster of embeddings, which would make the process really faster. And this becomes quite relevant when you look at the scope of our task. Here, new advertisements are popping up every day, and law enforcement needs some quick solution for that. And finally, as you also mentioned, our work covers the responsible guidelines that can somehow regulate the misuse of these authorship attribution methods. And while these guidelines are drawn upon from the general ethical AI research, none of them were directly applicable to authorship attribution methods. And at least we started something on those lines, and hopefully this would be extended to accommodate other coming modalities as well.
Thank you.
Thank you, Professor Nelen. The opposition will now be continued by Professor Barros. Professor Barros, welcome to Maastricht, even if it's online. Professor Barros was also a member of the assessment committee and is professor of data science and AI in the field of organized and subversive crime at the School of Humanities and Digital Sciences at Tilburg University. Professor Barros, the floor is yours.
Thank you very much for the kind introduction. I'm really very sorry that I can't be there, but the weather really didn't help. And it looks like the weather is chasing me, and this is right now the most subversive thing that is happening today. So I'm sorry for that. First of all, I would like also to congratulate you with an extremely interesting and relevant thesis, which is also very well organized and very well written, very easy to read. I was particularly happy to see that you tackled the complex technical challenge of authorship attribution in cyber-enabled illicit activities, while also addressing privacy and ethical considerations, which is extremely important nowadays, also for the legitimacy of the police and law enforcement. So it might not surprise you that my question touches a bit upon this. As you know, the performance of artificial intelligence models can vary significantly when deployed on data that differs from their training distribution. So the so-called distribution shift. Models that appear to be fair while in development may exhibit some bias afterwards when applied in a different context. As we know, unfortunately, criminals are extremely quick in adapting, and they don't really obey by any ethical or privacy constraints as we do. So I see here a sort of a friction between the proposed models that you have developed and actually how they will be used in practice. So I was wondering if you could elaborate on how do you see how to cope with that quick adaptation of criminals, because at a certain point they will know your research is going to be published, so they will know, at least the clever ones, the ones with money, they will follow it and they'll probably will adapt and they know where you're looking for. So I'm just wondering how could one keep the accuracy of the models and still adapt for that quick adaptation of the criminals.
Yeah.
Thank you.
Highly esteemed opponent. Thank you for your compliments. And to answer your question, I think this is one of the key questions that I've been tackling for quite some time, because this entire research is about chasing the criminals and not being ahead of them, which we almost never can be. But I touch upon two of those topics in the limitation sections. The first one being now, like you mentioned, as the thesis is published, nothing is preventing these criminals to just go on ChatGPT, for instance, and then just generate their advertisement through them, which would eliminate the element of stylometry. And this has been something that has been stuck in my mind for quite some time. I think I do not have a substantial answer for that question yet, because that would require us to recollect the advertisements from now and evaluate, first of all, if that shift has already happened. And secondly, if that happens, I'm hopeful that we would still be able to capture some elements of word choices, if not style directly, because to these large language models, you have to feed a prompt to get an answer from it. And the response directly or indirectly corresponds to the prompt that you feed to these networks. And so I'm a little bit hopeful in that direction that maybe moving on as we collect more and more advertisements from, let's say, 2024, 2025, we will see that these authorship attribution models, while they fail to connect the stylometric signatures of these authors, they're still catching up on some of the word choices and at least doing some part of the problem. Yeah. And so, yeah, that is all I can say for now. But thank you for your question.
Thank you. Thank you.
Yeah.
Thank you. Then the discussion will be continued by Professor Wilbig. Professor Wilbig is also member of the Assessment Committee and Professor of Data Fusion and Intelligent Interaction at the Faculty of Science and Engineering of Maastricht University. The floor is yours, Professor Wilbig.
Thank you, Mr. Prorector. Esteemed doctoral candidate, it was a pleasure to read your thesis. I compliment you with the good work, especially the detailed experimentations that you have made. Despite this good impression that your work makes, I'm still left with some questions that I would like to discuss with you. And actually, I would like to follow on your previous answer. It's you mentioned that your solution is not Gen AI proof, or is it proof?
Highly esteemed opponent, thank you for your compliments. I mean, like I said, I can't claim it for sure, but we have been collaborating with WebIQ, which is one of the Dutch companies targeting similar problems. And I brought some experiments to show what might be happening now in the scenario now. So we now have advertisements from 36 extra markets on top of what we already had before. And these advertisements are spread across different years. So as you can see, we also have some of the advertisements from the year 2025 and 2024. And as it turns out, the models are still reaching an accuracy of about 82% and a macro F1 score of 71% when trained on data pre-2020. So the training of the data is chosen such that we can try to get a generalized performance from the model during the evaluation as much as possible. And this generalization happens through the retrieval task that we have established in our research. So when we look at the R precision score, we get an R precision score of about 0.60 and on the training data and about 0.5297 on the test data. So test data being the data between 2021 and 2025. Now I know this performance sounds really bad, but you have to consider that now we are targeting 41,446 vendors. So now this tasks become extremely complex. We are looking into 36.28 million advertisements. And on those 36.28 million advertisements with 41,446 vendors, we are getting an R precision score of about 52, which is not bad considering that if you want to connect these advertisements manually, that would be practically infeasible. So I cannot answer your question directly because I really do not know that so far whether these vendors have adopted to large language models or not, but that is a good research question to target in future before we generate our new set of results.
And if you were given an opportunity, just hypothetically, how would you make your solution Gen AI proof?
I currently do not have an answer for that. I apologize, but I think this is a good direction to think upon in the future.
Okay, thank you.
Thank you. The discussion will be continued by Professor Bex, also present online, and welcome to you as well, Professor. Professor Bex, also member of the Assessment Committee and Professor of Innovation in AI and Law at the Department of Information and Computing Sciences and the School of Law of Utrecht University. And Professor Bex, the floor is yours.
Thank you. Let me start off, before I congratulate you with your beautiful thesis. If you do find the answer how to make these methods LLM-proof or Gen AI-proof, then please let me know, because we have a lot of students using Gen AI and I want to have Gen AI-proof ways of determining whether they wrote it themselves or not. But this is the big question we all stand for, right? I think your thesis is very good. I think also kind of academically, I think the technical work is very solid, more than solid. It's been published in ACL, EMNLP, very high-ranking conferences as long papers, multimodal work, very interesting. But I want to kind of step a little bit from so kind of 1 day a week I work at a law faculty. I want to take a little step towards the less technical part of your thesis and how that connects to the technical part. So that's chapter 5, if I'm correct, the responsible framework guidelines, I should say, for authorship attribution tasks. I have two questions, two main questions. The first one, maybe a short answer. So there's already quite a few of these frameworks. There's the FRAIA, the Fundamental Rights Impact Assessment. There's things like, there have been things like DPS, or Data Protection Impact Assessments, for a long time now, GDPR. All kinds of different how to use data frameworks for using data, using AI, impact assessments. What makes your ethical legal framework different from those assessments?
Highly esteemed opponent, thank you for your compliments. And to answer your question, we actually looked into quite a lot of frameworks during our extensive research. And we found that while these guidelines exist, they are not directly applicable to the authorship attribution tasks. Moreover, they are not designed for every stakeholder of the SDLD, software development lifecycle, and also they are not designed for allocating responsibility to each of these stakeholders in each of those phases. So in our research, we divide the entire software development lifecycle through the waterfall model, and we divide it into 3 phases named as planning, development, and deployment, where we have different stakeholders in each of these phases. We believe that by assigning responsibilities to each of these stakeholders individually, we can establish a much more responsible application rather than having these guidelines written on a generic sense. So to answer your question directly, I would say that our framework is different from all the existing frameworks because we assign not only responsibilities to each of these stakeholders, but we design the entire framework specifically for authorship attribution, text-based authorship attribution tasks.
Right. That's a good point, because then you say you base this on established software production frameworks. This waterfall is a well-known model, well, it's not an older one, but it's the one came before. And then at some point, people started working agile. those kinds of things. There's lots of requirement engineering, lots of the kind of software production methods have been around for a long time. So I again have two questions, and then the main question is that the waterfall, is the waterfall method as a kind of basis, is that even suitable for AI development? Also what the previous opponents already asked, well, they said criminals are working very fast, technology is progressing very quickly, right? So every month there's a new model that Google or OpenAI or Meta kind of brings out. Like waterfall is really aimed at sitting down with everyone, all the stakeholders beforehand, going through the whole thing, and then building your space shuttle or whatever you want to build, and that needs to be very clear. This is what we aim for. But if the goal is such a moving target, right? So kind of then maybe a new model comes out, or a new criminal. The criminals think of something else to build their to create, or to new writing styles, LLM used, and then a new model comes out that makes it easier to detect or harder to detect, those kinds of things. Do you think that waterfall makes a lot of sense for that? And if not, then, well, in hindsight, what could you have done differently maybe there?
Highly esteemed opponent, thank you for your question. And as you mentioned, from at least what I've read, the two very dominant methods in this area are the waterfall and the agile methods. And so the waterfall method basically depends upon planning before deployment, rather than agile method, which is basically focused on applying, learning, and then adapting from it. So here in this specific scenario, the cost for a mistake is quite high. For example, if we wrongly attribute one of the authors to an identity online and that person gets arrested, that cost is quite high. So that was my reasoning for not adopting agile approach. The waterfall model, as you said, is quite simplistic, but at least it focuses on planning before deployment, which was the whole point of our framework, because we wanted to establish responsibility and accountability from the start of the process, not after the entire process is up and running and learning from it.
But then, I mean, if I may, so there seems to be sort of the internal discussion, right? So kind of you want to kind of you want to avoid the risk. This is a high stakes environment, so you don't want people to shoot from the hip, be agile, and maybe you make some mistakes in with respect to, for example, biases or any kind of discrimination or whatever. On the other hand, there continued innovation, right? So maybe kind of have a think, and maybe you can tell me something about how to kind of, is it possible to reconcile these two? Because just waterfall, sitting down and planning beforehand, that's probably not going to work with the criminals and the models progressing as quickly as they are. On the other hand, you don't want to be too agile. Maybe you can kind of reflect on that a little bit.
Yeah, highly esteemed opponent. I apologize, but I do not have an answer for that right now. But I think that's a very good point, that how to make this entire framework more adaptive. Yeah, I apologize. Sorry, I do not have an answer for that right now.
That's fine.
Yeah.
Thank you.
Thank you so much. The discussion will be continued by Professor Moerland. Professor Moerland is Professor of Criminology and Law at our faculty. The floor is yours.
Thank you, Pro-Rector. Dear candidate, I have the honor to represent Professor Jill Koster van Voorhout, who was not able to join us today because she had other pressing obligations to attend to. However, she asked me to convey her compliments on your very interesting and relevant PhD, and she also wanted me to tell you that she regrets it very, very seriously that she cannot be here today. In preparation, I also read your manuscript, because also from a criminological perspective, as one of my colleagues has already mentioned, it is a very intriguing piece of research that you are defending here today. The question that Professor Koster van Voorhout and I want to ask you builds actually on the previous question. It also relates to the chapter 5, your last chapter. And in your last chapter, it includes responsible guidelines for authorship attribution tasks in sensitive domains through a structured questionnaire that guides practitioners in navigating the trade-offs, such as balancing investigative accuracy with privacy protection during model design, but also its deployment. And you propose to embed a range of ethical, legal, and social issues into the authorship attribution software cycle, so that a scholar can proactively mitigate the risks of misuse while aligning the technology with societal values and legal standards, specifically when using NLP. Now, we would like to ask you how specifically your guidelines would have guided you to conduct your PhD research. So in other words, if you would have had your guidelines at the beginning of your own PhD, how would that have helped your project? And having gained that knowledge, what would you recommend future PhD candidates? Would you do things differently? Or are there aspects following your framework to be very critically aware of? I'm looking forward to your answer.
Highly esteemed opponent, thank you for your compliments. I think this is a very interesting question because I suffered through it quite a lot. Coming from a technical background, I didn't have an understanding of GDPR or privacy concern. And it took me quite a lot of time to collect my data, but also to publish them ethically. So if I had known about a framework that existed like us, like what we pushed, maybe I could have drawn upon that before I started working on my data, which would mean that, for example, when I started the research, I started processing the advertisements on their entirety without worrying about the privacy concerns, like is there a name in the escort advertisement, or is there a location tagged there, or for example, is it harming anyone, and stuff like that. Coming from a machine learning background, that was quite the trend, just to throw everything into your model and hope something good comes out of it. But knowing about these regulations and knowing about these concerns, I had to redraft many iterations of my first paper when I was trying to publish, and especially the second and the third paper, because we were also releasing these data sets which were quite sensitive along with our research work. So had I known that, I would have approached this very differently, and I think, in fact, that should have been the first study I should have performed before moving to the technical study around it. Mm-hmm. So it would have saved a lot of my time and efforts, but more importantly, maybe this was the right way to follow. So I would suggest anyone who is looking into this field, first of all, to get familiarized themselves with the privacy concerns, with the fairness aspect. I think the fairness aspect is quite clear to most machine learning engineers, but the element of privacy is something that is not super clear to us. I think the other three pillars are quite straightforward, and I think this is all about maintaining good ethical standards, whether or not, if you want your research to be ethical or not. So I hope that really answers your question.
Mm-hmm. Briefly, a follow-up, because what I think is interesting, you say, okay, the guidelines are developed with regard to AA specifically, right? But when I hear the discussion also on what you say, if the general attitude was take things and throw it in the machine, I think maybe your framework has also implications beyond AA, no?
It could be, because we have divided the entire software development lifecycle of authorship attribution methods through this responsible framework. I think the takeaway from here is not only this framework, but how a particular machine learning operation can be developed around such similar responsible frameworks. So you can divide your machine learning application and then divide it into many chunks, depending upon which stakeholders are involved in your process, and what kind of applications you're targeting. And I think the takeaway is it's really possible for you to develop a framework around your machine learning applications before you deploy them. And in my opinion, this should also be the way, rather than just applying them and then learning about the repercussions.
Thank you. Thank you for your answer.
Yeah, thank you.
Thank you, Professor Moerland. The opposition will be continued by Professor Barros.
Okay. So my second question has a more practical sense, in the sense of law enforcement then. Your research reveals a lot of capabilities and interesting avenues for strengthening law enforcement capabilities. However, and in order for law enforcement to adapt it, it probably requires further steps, among which validation and training that you refer in your thesis. Could you elaborate, if you would have the choice, what would be your advice to law enforcement? Where do you think they should invest first? Because you also discuss in your thesis the importance of explainability. So I see a lot of avenues or a lot of research or a lot of things that have to be done before your methods can be adopted in practice. So given also the scarce capabilities and the scarce financial possibilities, what would be your recommendations? What kind of paths would you advise them to follow?
Yeah, highly esteemed committee member. Thank you for your question. I think to address all the concerns that you're pointing out, maybe we have to go back to the thesis itself, where I say that it's really important and crucial that law enforcement do not take the predictions out of our model as the evidence to their investigation. So we suggest that the problem is that we have millions of advertisements and it's practically infeasible for anyone to manually connect them. And so we designed a tool to just connect these advertisements and save resources for law enforcement before they start the investigation. But this is where their entire focus or emphasis should be, to just minimizing the amount of resources, minimizing the amount of advertisements that they have to monitor otherwise, and only use this as a starting point for the investigation. The point that you brought up about explainability is crucial. If they have some element of explainability, maybe potentially they can use it as a means of evidence, but that remains questionable because these models, not only they are not unpredictable through explainable methods, but also they are not super robust. So every time you train this model from a random noise, it generates a very different prediction. Not to mention that we have many platforms now to generate these explainability methods through just computing the attribution score, but at least our investigation revealed that each of those methods revealed a different explanation. So there's always a question of which platform to choose over which one, and I think this becomes really a challenging task in that sense. So I would rather say that, like, rather than focusing on explainability, maybe we need to pivot towards interpretability, where we try to understand what model has learned, rather than why is the model making certain prediction. And all I can say is, like, I want to be really careful about law enforcement directly using our platform to generate any kind of evidence. That shouldn't happen at all, and that is not what it was meant for. I hope this
Thank you.
answers
I'm
your
very
question.
glad with your answer, as I fully agree with you. But in terms of training, what would you recommend? Because usually law enforcement officers are not specialists in AI. So what kind of basic training would you advise them to get, and how should they use the methods that you have developed in practice? Do you have any thoughts about how that should be done?
Yeah, highly esteemed opponent. I think I do have some thoughts, but they're not concrete yet. And so I would just say that I'll think about it and I'll come back to you with an answer after I do my thorough research. I don't want to say something that's wrong.
Okay, thank you.
Yeah.
Thank you. Before I give the floor to Professor Wilbig, I would like you to step a little bit back and ask one of your paranames to read out loud Proposition 9, please.
Proposition 9, open source forensic AI tools expand analytical capability but simultaneously increase the risk of misuse by parties with malicious intent.
Thanks you so much, Mr. Louis. Professor Wilbig.
Thank you. I was wondering, how do you combine open science with risk of misuse? And this question is valid not only in authorship attribution, but actually for any AI-related research, and perhaps not only AI-related research.
Yeah, highly esteemed opponent. Thank you for your question. And can I ask for some more clarity on your question? Like, is it about how can open source tools be more accommodating to minimize the risk of misuse?
If you think perhaps internet or Gen AI can be used for good purposes, but at the same time with deepfakes, criminals can, for instance, imitate your voice and call your family friend saying, oh, I'm in trouble, I need help, send me money, and misuse the technology into fraud. Gen AI can help getting the answers, writing texts, but students may misuse it and write their reports. So were you giving, because you were working on this very sensitive topic, so were you also thinking about potential of misuse, and whether you have some thoughts about this?
Yeah, okay, yeah. A highly esteemed opponent. Thank you for the clarity. So while I was experimenting with different architectures, it came to my mind that any of these models can be used to target an individual, even outside the context of its application. So for example, you can use the same authorship attribution models and then apply them on social media websites to find a post by a very single individual person. And I think this needs to be avoided. So to circle back to what I've been saying, that the application of these methods have to be governed or regulated by a responsible framework around it. And everyone involved in the entire development of these applications should be accountable for each other, but also for themselves. As far as it comes to criminals applying or misusing or abusing open source techniques, I really do not have an answer for that. I think with your Gen AI remark, I would say that I'm not really an expert on that field because it's a little bit further away from what I've been working on. Most of the models that I work on are discriminative in nature, not really generative.
So would you be advocating, let's say, closing open science, not publishing, let's say, some sensitive results because they may be misused? Or still you believe in open science principles?
Yeah, that's a very good question, actually. So, of course, there's a need for open science projects, and I think there's no counter-argument to that. But those frameworks or methods can be more regulated by the people who are deploying these kind of services. So if you see someone misusing it for the first time, of course, you cannot do anything about it. But after it is being reported, and it's also a question of getting the feedback back from the user, whether or not if there has been a misuse or an incident around their framework, and then trying to regulate these models or methods such that these incidents cannot be conducted again. I mean, these incidents don't happen again.
Okay, so you think something about like ChatGPT having this security measures that if you ask questions about certain topics, you will not get an answer.
Yeah, definitely we can tread carefully. I don't think we can completely avoid the problem. This problem has been existing even beyond open source intelligence platforms, forensic science platforms. Atomic energy was never created to create a bomb, right? And so there has been, historically speaking, there has been many incidents where people have used a very specific part of science for their own benefit. So there's no way to completely avoid it, but I suggest that we tread carefully, especially with large language models, and at least have a responsible framework to regulate what is being generated or what it is being applied to.
Okay, thank you very much.
Thank you. Professor Becks, the floor is yours again.
Thank you. So continuing on with the generative AI discussion and LLM discussion, you said you're not much of an expert. You prefer discriminative models. On the other hand, it's everywhere, right? And as a computer scientist, you must have run into them once or twice in your research. So can you maybe you've done some experiments or already thought about it? How would your research, or if you would start this thesis now, right? Then how would you maybe use these bigger models? Because I think the biggest model you use is, I guess, Roberta, 125 million parameters. But there's now obviously also, if you send it to the types of conferences you send it to, one of the first questions is, why did you not use bigger models? Did you look at bigger models as well? Are there uses of these bigger models? How do you think they would maybe how they would perform on the types of tasks that you've done with your smaller models? And are there maybe other uses, maybe explainability or other uses that they could be employed for?
Highly esteemed opponent, thank you for your question. Yes, we do not use bigger models for our experiments, and the reason for that was to keep the research consistent. We started with a problem saying that law enforcement do not have a lot of resources. So deploying bigger and bigger models would be counterintuitive to that argument. And that was the reason why we wanted to keep the models on the smaller side rather than on the bigger side. But as you would see, as we move on with our research, we had to go into bigger and bigger models, especially when we started delving into multimodality. So my current objective, at least while I'm working with WebIQ, is also to identify areas of distillation where I can still bring down these bigger models into smaller architectures that can be run on everyday machine. But this problem is really difficult to tackle, because while I'm trying to distill these bigger models into smaller models, a lot of the information is actually being lost in this distillation process, or at least I have not achieved any success there yet so far. Secondly, these bigger models are pre-trained on a general language on the internet. And as we already show in our research, that there's a huge shift in distribution, not only part of speech distribution, but also otherwise, so language distribution in general, between the online internet spaces and these criminal spaces. So this pre-training is not really helping us even when we try bigger architecture. In the current research that I'm continuing, we have tried using XLM Roberta base, but we have also tried using the larger version of the model. And for some reasons that I cannot justify right now, the bigger models have actually a lower performance compared to the smaller models. And my intuition is that it's just that you always do not need more parameters to learn the task. Sometimes your models have the architecture which cannot implicitly learn the task. So it's not always that you can just train a bigger model and get a better performance. Sometimes they're not just meant to do that. So a specialized architecture would be a better direction to go rather than experimenting with bigger and bigger models. Especially when we experiment with multimodality, we see with these blip2 and clip models that the models were not able to associate text with images. And this is because that is how they were designed. They were designed to connect the captions of an input image, but here the task is very different. Here we want to associate a piece of text advertisement describing characteristics of an escort to the images of the escort itself. And yeah, we did try with Lava architectures after the research ended, and that yielded even worse results.
Interesting. And then maybe my final follow-up question is, So you work at, as far as I can understand, you work at WebIQ now. Do you guys, are you at liberty to say, do you intend to release these types of tools for, well, general use, or do you want to use them, the company wants to use them or work together with the police or other law enforcement agencies, directly using this authorship attribution for these kinds of tasks?
Yeah, highly esteemed opponent. Thank you for your question. To clarify on your question, I want to.
You're allowed to finish your answer.
Yeah, okay. Thank you so much. I'm currently collaborating with WebIQ. I'm not working for them, so we're still trying to deploy the entire research that I did during my PhD to their platform. But they do not want to directly apply this right away. We want to experiment with what they have, which is basically connection of simply private identifier to create these criminal networks versus the authorship attribution methods that can either better or perform either better or worse. So from the advertisements that we collected, only 9.6% of all advertisements had those private identifier. So a huge chunk of those advertisements are still not being connected, which is where authorship attribution methods kick in. But yeah, finally the goal would be to develop a service which would not be open source, but they would sell it as a service to law enforcement directly.
Thank you so much, Mr. Saxena. The time appointed for defending your thesis has passed. The degree committee will now withdraw to discuss the quality of your thesis and your defense. I request that you and your company await the results of our deliberations and our return in this room.
Thank you.
I will not ask what happened there. Dear Mr. Saxena, the degree committee here present has assessed the quality of your thesis and your defense. And in view of its positive verdict and taking into account your previous qualifications, the degree committee has decided to grant you the degree of doctor. Professor Van Dijk is authorized to confer upon you this academic distinction in accordance with Dutch university custom. I invite your supervisor to now take the floor.
All right, please.
Do you promise to work in accordance with the principles of scientific integrity at all times, to be careful and honest, transparent, independent, and responsible?
I do.
That's good news. By the authority vested in us by law and in conformity with the decision of the committee here present, I hereby confer upon you, Vageesh Kumar Saxena, the degree of doctor and grant you all the rights attached by custom and law. As evidence of this, I now present you with the degree certificate signed by the rector, the secretary, and the other members of the committee present, and affixed with the official seal of the university.
Thank you.
Very good.
Okay, dear Dr. Saxena, dear Vageesh, it is my honor, my privilege, and my pleasure to deliver this laudatio to you. You can safely guess that I'm doing this on behalf of both me and Gijs, and given that since 1 minute ago you have a PhD in authorship attribution, we can only assume that you can find out who prepared what. If memory serves me well, I think a PhD has been your dream since you were a teenager. So today I guess it's about dreams coming true, and I will take us a bit on a short historical journey on how this dream became a reality. So Vageesh applied to us back in 2020 with an impressive resume, publications, collaborations, and during his interview we were naturally impressed and also a bit puzzled by something he said, translating freely here, that he wanted to use data and AI to solve crimes and catch criminals online. Some might say this sounds a bit naive, perhaps a bit funny, but Vageesh was nothing but serious about it. Once we offered Vageesh the position, he did not immediately accept. Instead, he came back to us with 4 questions. I'm not sure if you remember them. I can remind you. The first one, where will I run my experiments and what servers I will have access to? The second one, can I pick the topic I want, how fast I can have to do it? The third one, can I publish in A-star conferences and are you okay with it? And the final one, a bit irrelevant now, is that how is the corona situation at the university? Given these questions, I think it's only a fully determined PhD candidate that should ask, and in retrospect, I think it was that very moment that determined that there was only one way for you, and that was to succeed. After accepting the position, Vageesh dismissed quickly many of the topics that Gijs and I suggested, as they did not sufficiently align with his goal. And this explained both his topic choice and his phrasing, quote, help law enforcement agencies, which in early supervision meetings we tried to systematically downplay, as it was not necessarily the purpose of his research. I also remember some discussion we had with Gijs on how to handle this, and eventually we concluded, let's give him some space and time to explore and find his space, and you did it successfully. You also connected with many companies during your PhD to get access to data that you could work with. You engaged with many colleagues at the law faculty, tried to explain and contextualize your research. You published your work in top natural language processing conferences, making the Law and Tech Lab worldwide known in this niche domain. And as a computer scientist in the law faculty, which I can perfectly relate to, you stepped outside your comfort zone and you excelled in exactly contextualizing your research and really explaining it to lay audience. As evidence of your hard work, you once framed a complaint to us that we don't push you enough and we aren't critical enough. And despite our assurances that we would be if needed, I think you still wanted more pressure, but honestly there was nothing more you could do during your PhD. To corroborate that, in that same meeting, I think the department head, present here as the prorector, concluded, nice guy. Vageesh is extremely sharp when it comes to his research and to technical topics, but sometimes a little naive about rules. I think he once failed to back up his DSRI data and nearly lost all of it. I think it was also nearing the end of your PhD. We asked, why didn't you make a backup? And Vageesh replied, because I thought the rule stipulated that we shouldn't leave potentially sensitive data in too many places. Which of course showed that you really tried to apply the frameworks you really worked on, but also begged the question, who doesn't back up their data? So the topic of Vageesh's research is highly technical, but his personality is certainly not. We always experienced Vageesh as a kind and genuinely people-oriented person. I think the best proof for this is that you finished your presentation with pictures of the people that many of them are here today. You also really wanted a research buddy, which you found in Antoine, one of your parents here today, and despite losing to him repeatedly in ping pong, of course it wouldn't be a proper laudatio without mentioning the ping pong gate between you two. Vageesh invited all lab members to his home in Aachen, where his wife treated us with lots of food. He was always there for drinks with the lab and very pleasant personality. He is a walking encyclopedia when it comes to food ingredients, perhaps because your dietary restrictions can single-handedly also ruin a conference, as happened in Singapore back in 2023, where for unknown reasons to us, only meat options were available. At the moment, you really suffered from hunger, while Shashank, who is somewhere in the audience, insisted on going or get another train ride at the Universal Studios. I guess, yeah, this really happened as I described it. So throughout your PhD, you often said you wanted to find a job in the industry after this, but who could blame you? And this is why we were especially happy when you decided to pursue a postdoc here at Maastricht University at the Department of Advanced Computer Sciences. After your interview with Christopher, right, you told me, yeah, it didn't go so well, which at the moment I really doubted it. And when I spoke to Christopher, he told me, well, he was the best. He really approached the topic in an exemplary way, and he did more than we asked. And from everything I hear in your new department, everybody has only good things to say to you. Before I close, also on behalf of HICE, I would like to thank the members of the assessment committee for reading the thesis, for contributing here today, either remote or on site, the prorector for guiding us through today, of course your wife for being here, your parents and your family who had to change plane tickets and stay without overextending their visas. That is very much appreciated. And of course everybody else joining us here or online to share this moment with you. So to return to the beginning, dreams do come true, but only for those who are willing to work with them, for them with patience, integrity and curiosity. You really wanted to include a quote from Carl Sagan in your propositions, and that inspired me to include one here. Science is a way of thinking much more than it is a body of knowledge. And throughout your PhD, I think you have embodied exactly that. A way of thinking that is rigorous yet reflective, technical yet responsible, and always mindful of the broader implications of your research. So me and Gijs would like to congratulate you not only on your PhD thesis, but on the researcher, the colleague, and the person you have become. Your dream only continues now, and we very much look forward to see what you are going to achieve next. Once again, congratulations and all the best for your next steps.
Thank you so much.
Professor Vanakis, thank you so much for this wonderful speech. Dear Dr. Saxena, also on behalf of Maastricht University and its Faculty of Law, I warmly congratulate you on the degree you just have acquired. My congratulations go also to your promoters, to the team, to your family and friends here and online. You are a nice guy and stay a nice guy. Dear ladies and gentlemen, it's with pleasure that I invite you to the reception that will take place in the refectory. The committee here will stay in the room to make a picture with the opponents online. Afterwards, we will go to the stairs in this beautiful building. There also will be taken a picture, and afterwards we will join you in the refectory for the reception. Having said this, I close the ceremony.